So today we're going to talk about linear combination and span as part of linear algebra. So just some definitions. The linear combination of vectors, for example, u and v, is w equals au plus bv, where a and b are real numbers. So basically this is any combination of u and v with any coefficients. So that says a specific addition of multiples of u and v. In 2D space, this will create a plane, and in 3D space, it will create a parallelepiped. And in more than 3D space, we just call it a hyperplane. So hyperplane is formed as a result of the linear combination of two vectors. The span of two vectors is all possible linear combinations of these two vectors. So in both 2D and 3D space, the entire space is represented by the span of the two vectors. Now, if we want to find out if a line is within a span, we can follow this procedure. So we want to write the linear combination expression for the vectors. Then we want to choose arbitrary points from the equation of the line. Then plug in the points to create a system of equations and solve the system of equations. If finding coefficients in the span expression is not possible, then it is not part of the span of the given vectors. So we're going to go through this video example here. So we want to express w as a linear combination of u and v, and same thing or similar concept for the extra example as well, which will be linked. So we'll go ahead and do an example. So w is -2, 5. U is 4, 3. And V is 1, 3. And we want to express W as a linear combination of U and V. So what we're going to do is write out that expression. Where A and B are real numbers. So then we can just plug in here the vectors. So it doesn't change the expression at all, but we just say -2, 5, which is W, equals A, 4, 3, which is U, plus 1, 3, which is V. Sorry, that should be B, 1, 3, which is vector V. And then we can create a system of equations. So, for example, we know that something will have to add up to 2 using those first terms in the vectors, and something will have to add up to 5. So we'll go with the 2 first. So -2 equals 3a plus 3b, and then 5 equals 4a plus 1b. And then all we have to do is simplify this, solve this linear equation, the set of linear equations. And how I'm going to do it is I'm going to multiply this by -3 and then add them together. So we'll just rewrite this. -2 equals 3a plus 3b, and then -15 equals -12a minus 3b. add them together. So then we can solve for one variable at least. So then these cancel. And we're left with negative 17 equals negative 9a, which means that a is equal to 9 over 17. And we can plug that back into one of our equations. Let's say, we can say the first equation. So we can say negative 2 equals 3, 9 over 17 plus 3b. So then negative 2 equals 27 over 17 plus 3b. And this might get a little bit complicated, so I'm not going to simplify, but you could. So that would be negative 34 over 17 equals 27 over 17 plus 3b. So 34 minus 27 would be negative 61, if I did that correctly, over 17 equals 3b. Therefore, b equals negative 61 over 3 times 17, which I don't have offhand, so I'll use a calculator. $51. And that is how you solve it. So then you can put a and b back into this equation up here. That is everything for this week. Thank you very much, and we'll see you again next week.